Life is not a machine or a ghost. The naturalistic origin of life's organization and goal-directedness, consciousness, free will, and meaning. Marsha Familaro Enright. Published July 2023, Journal of Ayn Rand Studies. Abstract. Due to a widespread belief in mechano-reductionism, most intellectuals reject the idea that non-conscious living beings act toward goals. Proposing otherwise is mostly rejected as unscientific anthropomorphizing or necessitating appeals to a supernatural power. This false dichotomy has stymied biology and its related sciences. Herein, I present a new naturalistic gestalt on the nature of life, one based on facts and evidence. It incorporates Ludwig von Bertalanffy's and Arthur Koestler's theories of systems and hierarchies with the ideas of Aristotle, Jonas, and Ayn Rand to identify fundamental formulations on the nature of life, consciousness, free will, and meaning. Ayn Rand and Philosophy of Biology. Can Rand's use of goal-directedness be founded in fact? Ayn Rand maintains that her ethics is based on the choice between life and death, and the argument at the base of her meta-ethics depends upon the ideas that life is a goal-directed process and that human life is an end in itself. Her outlook here is biocentric, dependent on life having certain characteristics. But philosophy of biology is not a topic upon which she dwells. Despite the Darwinian/existentialist sound of the choice between life and death, at first glance her ideas about biology do not seem to comport perfectly with the typical philosophy of biology that one encounters in book after book today. Contemporary thought about biology has an odd squeamishness about life being goal-directed or an end in itself, and seems less than comfortable with the idea of life being a continuing effort to avoid death, even though Darwin adopted survival of the fittest as an alternative description to natural selection. Darwin, 1866. This discomfort manifests itself in apparently paradoxical positions, which we will explore herein, with an aim to urging theoretical reform to avoid self-contradictory claims. As we will see, in contemporary thought, living things are often considered as acting as if they had goals, but with a qualification that this is merely an as-if imposed by the human mind, not a true underlying reality. The irony is that everyone knows that living things act to survive and reproduce, but then many claim their processes are just inanimate chemical and physical actions. So which is it? Are the processes of living things actions, or are they just a bunch of reactions? The contradiction is so well accepted, few are aware of it. Rand's approach seems to line up with an Aristotelian view that goal-directedness is not an imposed human interpretation, but an underlying metaphysical fact. Still, the question remains, in a non-deistic universe, how might goal-directness arise or be understood? One major perplexity that gives rise to this view is, how can non-conscious action, that is, vegetative action, occur for the sake of a condition, the goal, which exists later in time than the action? Without consciousness, by what means does the action move toward the goal? This is a kind of action at a distance problem. Purposeful action of conscious beings is often considered the paradigm case for teleological action. The idea of teleological action may derive from our direct introspective experience. We know that we can imagine an end or value, desire it, and put in motion the actions to obtain it. In purposeful action, the awareness of a desire or value causes the agent to undertake the action toward the goal. This is how a future condition can motivate a present action. The vegetative action of plants, archaea, bacteria, and the automatic functions of animal bodies, such as digestion and respiration, have no organs in themselves by which to be aware of values and thereby act towards ends. How, then, could the benefit of the goal be a cause of vegetative action? By what means is the value of a future state causing present action? One way to characterize the Darwinian view of adaptation is, organisms act like they do because that's what they did before. In this view, organisms are not pursuing current goals for their own sake, but because they are similar to past goals, and because pursuing such goals has resulted in survival in the past. The problem is, the organism and its descendants may have been smart enough to learn from their actions, but how did the first organism manage to take those actions the first time? Was it completely random? Is the whole history of life one long series of felicitous accidents? That seems to be the answer of the neo-Darwinians for over a century. Yet life displays an enormous creative power to fulfill its self-perpetuation, its survival. Can we explain how new adaptive actions arise other than by accident or chance? What explains life's creativity? The answer to those questions would go far to solve the problem of vegetative action. The history of life is the history of ever-changing forms, new ways of fulfilling life's goal of self-perpetuation. Its history is replete with the coming into existence of new forms, new characteristics, new abilities. Certainly, like the knowledge of a conscious being, these are not created ex nihilo. That is, there must be some relationship between the new forms and abilities and the old ones. But the mere repetition of old forms of action is not an adequate description of living action. The widespread answer is a mechano-reductionistic approach to biology and a too-behavioristic view of psychology. For example, a typical explanation of why a dog seeks pats from humans is that it remembers liking pats in the past, an associationist view of dog action. Surely, once the dog has received and enjoyed pats, the memory serves as motivation. But this explanation gives no consideration as to why the dog sought pats in the first place, and yet, anyone who has observed animals knows that they initiate all kinds of actions. They seek, they explore, they try things out long before they know what the consequences will be. Purposeful behavior can be self-initiated in a way that doesn't necessarily depend solely on past experience, either personal or evolutionary. In general, the mechanist approach to living action is unfortunate. It is the explanation that all life can be explained like a machine. However, machines operate automatically to achieve ends set by humans. They do not creatively change their actions in order to continue on pursuing their goal of self-maintenance and self-generation the way living things act. Organic behavior is characterized by its variability in the face of obstacles in order to reach its goals. A plant will grow in one direction, and then another and another in its attempts to go around a rock and reach the sun. Ludwig von Bertalanffy, who wrote extensively on general systems theory, called this characteristic the equifinality of living action. In other words, the means vary, the end remains the same. In fact, the exploratory actions of conscious beings are like the multiple attempts of vegetative organisms to reach goals. The constant in the actions is the attempt on the part of the organism to fulfill its needs, its pursuit of values. Let's look back at the nature of conscious action to see if we can understand how vegetative action operates. When an animal is born, it has an internally generated set of needs and of actions it can take to fulfill those needs. It moves and acts in attempts to fulfill its needs. Often the more intelligent animals explore. They try all kinds of things without apparent ends in mind, but with, apparently, the need to find out about the world in order to learn how to live in it. During their explorations, they discover that certain actions cause certain desirable need-fulfilling results, like getting a pat on the head from their master. Consequently, they repeat these actions because they now know that they will have valuable results. In my analysis of this sequence, the animal's original actions were not random or accidental in origin or intent. They were taken for the purpose of finding out how some need could be fulfilled. The exploratory actions were quite goal-oriented, that is, to the internal goal of fulfilling a need of the organism. Once the animal discovered by what means it could fulfill that need, it learned to take that series of actions again. Its apparent goal became the pat on the head. But ultimately, its goal still remains the fulfillment of its needs. in the process of self-maintenance and self-generation. This applies in a parallel manner to vegetative action. The organism, whether it be a plant or the vegetative levels of an animal's being, has a set of internally generated needs to fulfill, and of abilities or actions it can take to fulfill those needs. It moves and acts to fulfill those needs. It grows one direction to reach the sun, then another, until it finds the direction of sunlight and gets around that rock. The fulfillment of its internal needs is the goal toward which it is acting, until it achieves the values that fulfill those needs. That is the nature of life. Thus, the problem of the means by which vegetative action is directed to a future goal evaporates, because the goal of vegetative action is always the fulfillment of the present needs of the organism. As far as the creation of new modes of action, just as organisms continuously rearrange the sequences of actions that they take to reach external goals, so I think they rearrange their internal sets of abilities to create new modes of action and new values. This is certainly the case in the development of creative thinking. And on the biological level, the origin of such complex systems as the liver are too unlikely to happen by a long series of chance mutations and are too obviously functional as a whole system in promoting the well-being of the organism to have been caused by accident. As some believe, we may get our idea of goal-directed non-conscious action, vegetative, from our own experience of conscious, purposeful action. Yet in the end, purposeful action is just another expression of life's basic nature, its ability to act toward goals. It may be that in the ontology of concepts, teleology comes from purpose, but in the ontology of being, purpose comes from teleology. One writer, Harry Binswanger, attempts to explain the goal-directedness of vegetative action in his book, The Biological Basis of Teleological Concepts, 1990. He argues, likewise, on the vegetative level, teleological explanation, I will argue, is not an irreducibly separate kind of explanation, but is rather a less detailed form of ordinary mechanical explanation in terms of efficient causes. 39. The view I am defending, on the other hand, assigns causal efficacy only to efficient causes, but distinguishes between two kinds of efficient cause, proximate and ultimate. 86. But he then describes the proximate causes as 1. The fuel, and 2. The directive mechanism, whose existence, organization, fuel, and terms of operation result from the survival benefit that past instances of the goal have provided the organism in similar previous circumstances. 88. And he quotes Simpson as saying, "To understand organisms, one must explain their organization." 82. How is the mechanism directive? What does organization mean? The Oxford English Dictionary defines organization as the action of organizing or condition of being organized as a living being, connection or coordination of parts for vital functioning. What do the terms directive and organization imply but goal-oriented functioning? This makes the proximate causes already goal-directed in themselves, apart from any consideration of any ultimate goals toward which they may be directed. It seems as if final causation, ultimate causation, is included in his very concept of proximate cause. And that is not surprising, because I don't think that one can, in fact, reduce the proximate causes to mere mechanical causation. Life isn't like that. A neo-Aristotelian defense of goal-directedness. I propose we restart and look at the problem afresh. Is there a way to maintain a secular, scientific worldview which nonetheless embraces goal-directedness? Frequently, we encounter efforts to establish goal-directedness that are very far from scientific. The universe is alive. The universe has a living force in it. Spirits exist. The force is an energy field created by all living things. The scientifically minded eschew these ideas as poppycock. Science attempts to explain everything by reduction to the elemental characteristics of matter and energy, physics and chemistry, that is, by the inanimate, dead actions of elements in the universe. This view is called material or mechano-reductionism. And certainly, the application of physical principles to understanding nature and to creating machines has been an enormous boon to mankind. To be clear, I can only agree with Paul Weiss, 1969, who said, "Nothing that I am saying about molecular biology should be construed as a lack of appreciation of the tremendous advances made in that field. It's only a warning against the monopolistic position often taken there." 48. Ditto the rest of the life sciences. Yet, if you look at living things in the most fundamental way, they tell us something wondrous about the nature of the universe, namely, that there is a strong tendency, in some conditions, for matter to make itself into forms that collect energy, and more matter in order to be self-perpetuating, to stay alive, to survive, flourish, and reproduce. These forms act toward ends, for example, goals, in order to stay in existence. Staying in existence is their ultimate goal, and that is their essential nature. When I was a child, I eagerly looked forward to watching Flash Gordon on TV every Sunday, one of the first sci-fi programs. In Flash Gordon's trip to Mars, a villainess, Azura, uses a neutron ray to transform men into clay, where they live in caves, the clay men. During the episodes, they emerge from the clay walls as whole beings. The nature of life reminds me of the clay men. At the start of the known universe, after the Big Bang or whatever created the current configuration, there was just inanimate matter. Yet millions of living things emerged from dead clay and rock. Isn't it a marvel? I walk my dog and think of all these living things, like Mars's clay men oozing out of the material of the earth through their own self-organized energy. Just look around at your cat, your wife, the grass, and think of them as inanimate matter that has organized itself to become a process of self-perpetuated existence, that collects energy and uses it to put and keep itself in motion. This is the organic. And a key implication of these facts is, since life exists at least on Earth and likely other places in the universe, then the potential for life and consciousness and spirit one have always existed in the universe. One example, Hydra, is a small sea creature. Hydra's regenerative ability allows it to regrow complete body parts that become injured or amputated. Hydra are known to be immortal. Their stem cells continuously generate new cells to replace old ones. Hartley, 2017. Further, Hydra reproduce asexually so that the colony of Hydra are clones, for example, replicas. Life's ability to be goal-directed is not bizarrely unnatural just because it does not act merely by the known laws of physics and chemistry. It acts through abilities that emerged from a natural process via life's special organization of elements. Under certain conditions, certain materials such as carbon, oxygen, hydrogen, and nitrogen have a strong tendency to form into dynamic configurations. These configurations have a characteristic fundamentally different from inanimate matter. They originate action from within themselves and act to sustain their configurations and that of their kind. The fact that some elements of reality have the strong ability and the tendency to form living things are inexplicable by mechano-reductionist theory. Thus, proposing only a mechano-reductionist scientific view gives people reason to think that the universe has a mystical life force in it. Unfortunately, science's inability to explain how life happens encourages supernatural explanations. Can we discover naturalistic, non-mystical explanations for these facts? Ayn Rand, 1964, essentialized the nature of life as a process of self-sustaining and self-generated action. If an organism fails in that action, it dies. Its chemical elements remain, but its life goes out of existence. Life has the capacity for self-generated, goal-directed action. On the physical level, the functions of all living organisms, from the simplest to the most complex, from the nutritive function in the single cell of an amoeba to the blood circulation in the body of a man, are actions generated by the organism itself and directed to a single goal, the maintenance of the organism's life. I use the term goal-directed in this context to designate the fact that the automatic functions of living organisms are actions whose nature is such that they result in the preservation of an organism's life. 1616N. Here we have the essence of life, of biology, philosophically set out. Living things are goal-directed things, unlike the inanimate. The very thing that makes something alive is its consistent actions to keep itself and its kind in existence. Their entire beings are organized to do this, ordered in a goal-seeking manner. Of course, humans can create machines or processes that act toward a human-designed goal, but these are not organized toward survival and are a result of human purpose. Let me be utterly clear. All living things are a structure and a process such that they can act toward the goal of maintaining the existence of their process. This is what it means to act for their survival. This understanding is in stark contrast to that of the material determinists, which is the source of mechano-reductionism. Starting with the ancient Greek materialists, but especially since Descartes, Hobbes, and others at the time of the scientific revolution, thinkers have jammed living things into a mechanistic model. Descartes, 1633, stated, "I should like you to consider that these functions, including passion, memory, and imagination, follow from the mere arrangement of the machine's organs, every bit as naturally as the movements of a clock or other automaton follow from the arrangement of its counterweights and wheels." 108. Living things are automata, as Descartes described them. His view that human soul was entirely supernatural in origin, while all else was determined material, his dualism, is one of the foundations of the spiritualist-materialist dichotomy rampant in Western thought. The mechanical outlook is so deeply embedded in current thinking. Scientists and laypeople alike use it everywhere without recognizing that it doesn't describe living action. From scientific papers to podcast commentators such as Sam Harris to Wikipedia entries, academic and communications media are rife with terms such as the mechanisms of the brain or DNA's mechanics. For example, Harris, 2012, says in a blog post on the illusion of free will, "As sickening as I find their behavior, I have to admit that if I were to trade places with one of these men, atom for atom, I would be him. There is no extra part of me that could decide to see the world differently or to resist the impulse to victimize other people. Even if you believe that every human being harbors an immortal soul, the problem of responsibility remains. I cannot take credit for the fact that I do not have the soul of a psychopath. If I had truly been in Komisarjevsky's shoes on July 23, 2007, that is, if I had his genes and life experience and an identical brain or soul in an identical state, I would have acted exactly as he did. There is simply no intellectually respectable position from which to deny this. The role of luck, therefore, appears decisive." And in another entry, 2014, Harris says, "If there were evidence for dualism, immaterial souls, reincarnation, one could be a scientist without being a materialist. As it happens, the evidence here is extraordinarily thin, so virtually all scientists are materialists of some sort. If there were evidence against evolution by natural selection, one could be a scientific materialist without being a neo-Darwinist. But as it happens, the general framework put forward by Darwin is as well established as any other in science. If there were evidence that complex systems produced phenomena that cannot be understood in terms of their constituent parts, it would be possible to be a neo-Darwinist without being a reductionist. For all practical purposes, that is where most scientists find themselves, because every branch of science beyond physics must resort to concepts that cannot be understood merely in terms of particles and fields." Emphasis added. In these quotes, Harris demonstrates his acceptance of the dichotomy between spiritualism and materialism, and his deterministic materialism leads him inevitably to a denial of free will, while at the same time acknowledging that science has not been able to explain all through reductionism. But viewing living things as machines is metaphorical thinking. 2. Living things move and act in a very different way from the mechanical. We easily and obviously distinguish between the actions of a machine and that of a living thing, so easily that even children recognize the difference in cartoons. A key feature of living organization is that the living thing does not act like an automaton. Its actions are varied and can only be adequately explained by those concepts which imply acting toward ends, something extensively recognized by Aristotle millennia ago, as noted by Gotthelf and Lennox, 1987, 213. There have been attempts to address this problem among philosophers, especially with the issue of functions, some starting in the 1970s with the work of Larry Wright, 1973, Robert Cummins, 1975, and Jerry Fodor, 1974. Yet the main quandaries remain. The ability of living things to act toward ends is made possible by the ability to direct their processes and actions from within themselves. They are not like rocks or billiard balls, merely subject to the forces from without. Living things respond to outside forces in such a way as to keep themselves in existence. When a billiard stick comes close to hitting a mouse, the mouse doesn't just sit there like a ball and get hit. It jumps over the side of the table to escape. This ability to act in response to forces in the environment is what is often called adaptation. This ability implies that the essence of life is creativeness, the ability to take elements of the universe and rearrange them to grow and maintain the particular life system of the particular organism. The further implication of this is: 1. Evolution is a result of this creativity. 2. Human mental creativity is an evolutionary development of this ability. In fact, the human ability to mentally direct what one is paying attention to and to consequently direct one's thinking, responses, and actions is the evolutionarily latest manifestation, the latest development, in life's fundamental ability to direct its course of action. This is the essence and source of free will, and the very nature of life is the source of values and meaning. This sequence, from simple self-direction of unicellular organisms to the self-direction of the human mind, is the naturalistic contiguity of existence from inanimate elements to the power of the human mind to reshape reality for human needs and life. No supernatural power is needed. Self-direction is the basic function of living things. This will be explained in greater detail. But first, let's examine more of what has made it difficult to recognize these basic facts. Life and energy. The first law of thermodynamics, the law of conservation of energy, states that the total energy of an isolated system is constant. Energy can be transformed from one form to another, but can be neither created nor destroyed. The second law of thermodynamics is stated variously. Planck's definition, 1897-1903, is every process occurring in nature proceeds in the sense in which the sum of the entropies of all bodies taking part in the process is increased. In the limit, that is, for reversible processes, the sum of the entropies remains unchanged, 100. It is usually rephrased as disorder, entropy, always increases in a closed system. Physicists usually take the universe to be a closed system that is ever increasing in disorder, entropy. 3. Yet look at the life all around you. This natural phenomenon by which matter of certain kinds uses energy to stay in motion and matter around it, to keep its formal structure in existence. Observe all the different forms and their immensely varied characteristics. The one-celled and primitive multicelled forms, such as amoeba and slime molds, which incorporate matter and energy from their environment to maintain and reproduce their structures. The plant forms, ranging from algae to sequoia trees, which capture energy from sunlight and air and matter from the environment. The animal forms from dust mites to dinosaurs, which move around and acquire and incorporate matter and energy from other life forms. They all act to stay in existence. They act to stay alive, to survive. They do this by means of capturing energy and matter. They act against an apparently basic physical law of the universe. They are anti-entropic. Powerthesaurus.org lists growth, creativity, improvement, regime as the antonyms of entropy. All are terms applying to living things. The term shapeless rock highlights their difference with the inanimate. Living things develop geometrically regular and symmetrical shapes to be part of their energy capture systems, their conservation process, it seems. Scientists have a raft of knowledge as to how living things materially accomplish these acts of self-maintenance and self-sustenance. Cells, lipids, proteins, and nucleic acids are all part of it, as well as structures such as organelles, leaves, and skeletons. From the multiplication of rabbits to the growth of artichokes, the regularity of Fibonacci sequences characterizes living organization. Rand, 1964, indirectly addresses this issue. There is only one fundamental alternative in the universe: existence or non-existence, and it pertains to a single class of entities, to living organisms. The existence of inanimate matter is unconditional. The existence of life is not. It depends on a specific course of action. Matter is indestructible, it changes its forms, but it cannot cease to exist. It is only a living organism that faces a constant alternative, the issue of life or death. 15. A rock, of course, can be destroyed, go out of existence, but it doesn't face existence. That is, it has no power to keep itself in existence. A living thing does, and that makes all the difference. A living thing has a structure that enables a process of self-maintenance and self-generation. Life is fundamentally creative. Now when you look around at all the trees, birds, flowers, dogs, or watch a National Geographic show about the multitude of animals on the African plain, or marvel at the billions of tools in a hardware store created by living things, you can see them as the forceful expression of the creativity of life, reshaping the material of the inanimate and the animate into what sustains them. I want to underline this as a gestalt shift position. The ability to form into self-perpetuating, goal-directed entities is a natural quality of matter in certain conformations, carbon in particular in combination with other elements, apparently because of their specific physical conformation and properties. 4. This tendency is amazingly strong as shown by the fact, discussed in detail on the Human Origin Project website, that life has been wiped out almost entirely on Earth and partially destroyed multiple times, and yet has come back with more, new, and different forms. The Earth formed approximately 4.5 billion years ago, U.S. Geological Survey, 1997. The first life on Earth showed up 3.7 billion years ago in Greenland, then a seabed, and it wasn't until 2.1 billion years ago that photosynthesizing cyanobacteria revealed themselves in the fossil record, producing oxygen. 900 million years later, multicellular organisms evolved, and then 540 million years ago, Earth experienced the Cambrian explosion, in which huge numbers of species developed, including animals with skeletons. By 440 million years BCE, most of life was wiped out in the Ordovician-Silurian mass extinction. It came back, and then at 365 million years BCE, the Devonian extinction wiped out many tropical marine species. After repopulating, the Permian-Triassic extinction killed many vertebrates around 250 million years ago. But by 200 million years BCE, dinosaurs dominated the planet. Then, 66 million years BCE, the Cretaceous Tertiary event wiped out the dinosaurs, and tiny mammals had room to evolve into a diverse group. The last extinction event, 10,000 years ago, Younger Dryas, wiped out most of the megafauna on Earth, such as woolly rhinoceros, giant beavers, and glyptodons, and humans were reduced to a population of about 12,000, almost gone. Yet here we are today, 7.9 billion and counting, our ability to reason enabling us to rearrange our environment in a plethora of ways for our flourishing. Life keeps coming back, again and again, and faster in all kinds of old and new forms. Life keeps itself alive. Almost all species that have ever lived on Earth, once estimated at 5 billion, McKinney 1997, 110, are believed to be extinct, Stearns et al. 2000. Miller and Spoolman 2012, 62, estimate that there are between 10 million and 14 million today, but only 1.2 million have been documented, and 86% have not yet been described. Mora et al., 2011. However, a report from the National Science Foundation, 2016, estimates that only 0.001% of species have been described of 1 trillion species currently on Earth. The bee pollinating flowers, the anaerobic thermophilic bacteria living in the Marianas Trench, the tardigrade that lives in almost any environment, life is everywhere we can see on Earth in a variety of forms. Once this self-generating, self-maintaining process got started, it was amazingly self-sustaining, creatively changing to fit vastly different conditions and develop different modes of survival, from ctenophores to sloths to halobacteria. A remarkable illustration of this is the fact that ctenophores use a different set of neurotransmitters and have a different neural organization than other creatures. Moraz and Cohn, 2016, state. We conclude that acetylcholine, serotonin, histamine, dopamine, octopamine, and gamma-aminobutyric acid, GABA, were recruited as transmitters in the neural systems in cnidarian and bilaterian lineages. By contrast, ctenophores independently evolved numerous secretory peptides, indicating extensive adaptations within the clade and suggesting that early neural systems might be peptidergic. Comparative analysis of glutamate signaling, SIC, also shows numerous lineage-specific innovations, implying the extensive use of this ubiquitous metabolite and intercellular messenger over the course of convergent and parallel evolution of mechanisms of intercellular communication. Therefore, 1. We view a neuron as a functional character, but not a genetic character, and 2. Any given neural system cannot be considered as a single character because it is composed of different cell lineages with distinct genealogies, origins, and evolutionary histories. And the fact that life came back again and again after planet-wide extinction events demonstrates the strength of its forces and its tenacity. Until life's ability to act toward ends is understood as a natural power, as scientific a fact as F equals ma, humans will continue to have myriad confusions and feel the necessity to posit an outside power, a god or supernatural force, to explain this obvious fact of life. As long as the materialist paradigm reigns, scientists and others who do not think the evidence shows that supernatural powers exist will insist on ignoring or rationalizing obvious conclusions about how life works because its characteristics don't fit the paradigm. This will continue to be a negative force in the development of science. Furthermore, it will continue to negatively affect human culture because people will either be unable to find meaning in life as merely matter or feel the necessity to create gods to give them meaning, purpose, and morality. 5. The consequence, a breakdown in the scientific grounding for ethics and ultimately politics, and therefore society and a good human life. As Dostoevsky's character even says in The Brothers Karamazov, without God and the future life, it means everything is permitted now. One can do anything. 1990, 589. Existentialism, postmodernism, and all those philosophies that eschew objectivity in knowledge, values, ethics, and the human spirit will continue to pull civilization down the rabbit hole of depression, destruction, and chaos, which is culturally rampant today. An impoverished sense of existence will reign. So, what led science to this situation, and how do we approach the problem? From a hard-headedly scientific and rational point of view, is there anything to the claims that there is a living force? From a hard-headed rational view, yes, there is, but not in the way in which it has been conceived of up to this point. More on the problems with material reductionism. Scientific blindness in the face of overwhelming evidence results from the false dichotomy between scientific material reductionism versus mystical origins or God-created purposefulness of life. This blindness is facilitated by numerous expositions of scientific dogma, such as Richard Dawkins's The Blind Watchmaker, Why the Evidence of Evolution Reveals a Universe Without Design, 1986. In this book, Dawkins argues against William Paley's 1802 watchmaker analogy in natural theology, or evidences of the existence and attributes of the deity. Instead of a deity designing the course of evolution, Dawkins argues that randomness combined with natural selection can lead to cumulative changes over the course of time, such that, for example, a simple light/dark photoreceptor can be evolved into the complexity of a human eye. The problems with this argument will be addressed later. Material/mechano-reductionism claims that all living processes can be reduced to and explained by the mere physical and chemical processes of their constituent parts. In this view, a system is merely the sum of its parts. But consider the following. 1. Living things are able to contend with their environment in highly creative ways, whether it's monk parakeets from Argentina flourishing in the frigid winter temperatures of Chicago by building nests in electrical towers, as detailed in Wood, 2019, or a paramecium partially dividing, then uniting again as it attempts to deal with loss of water, Feynman, 1985. 2. As Bertalanffy, 1952-2 notes, Driesch made the astonishing discovery that a sea urchin embryo that he divided at a very early stage, just a few cells, does not die and does not form into two halves of a sea urchin, but rather into two perfect whole animals, basically identical twins. 3. That evolution happened is clear from the evidence, and natural selection is almost universally accepted as the main how, but natural selection works on living things that already have particular characteristics. How new characteristics arise is mostly a mystery. The standard, mechano-reductionist explanation is through a long accumulation of random mutations of genes. A deep problem with this hypothesis, which has been known for over 100 years, is that random mutations are almost always deleterious. How does a long series of deleterious mutations add up to characteristics that are beneficial and advance life? A recent study, Sawyer 2007, once again demonstrates it with Drosophila genes. In fact, as discussed by Fitzgerald and Rosenberg 2019, there are recent arguments against random mutation and for mutation to be instead an organismic response to the organism's needs. 4. Fleming, 2016, points out that forms as bizarrely different as the octopus and the human have monocular vision, one of many examples of the remarkable fact of homologous evolution, different paths to the same goal of function. 5. Abiogenesis, how life started, is an unresolved question, despite considerable knowledge about life's most basic elements, such as RNA and DNA. The exact path is unknown. The most widely accepted hypothesis argues that there were multiple events early in Earth's history, a series of molecular developments that included the beginnings of self-replication and self-assembly, autocatalysis, and the development of cell membranes. 6. Life still has not been artificially created. 7. Heck, the actions of rats have not been consistently predicted, yet modern science continues to view life through the mechanistic lens. The use of the term mechanism to describe the processes of life is ubiquitous. Modern science is painfully Procrustean, cutting off its legs to jam itself into the bed of materialism. It displays remarkable pretzel twisting to avoid admitting that living things act toward ends. Consciousness exists. Humans have free will. Part of the problem is that each of us can see how our minds imagine a goal and guide our actions to obtain it. But scientists cannot figure out how a non-conscious being could do the same. At least, they haven't been able to figure it out merely with reductionist tools. So instead, explanations of living phenomena via the goal-directed nature of living action are denied, often as anthropomorphic. Some neo-Darwinian contortions. Around 1991, I was at a conference on evolution in Chicago at the Field Museum led by lights of evolutionary theory such as Ian Tattersall. I was amused to hear speaker after speaker talk about evolution and life using such terms as directive mechanism, seeks, and ends. In other words, terms implying goal-directedness, then stop mid-sentence to disavow the terms with comments such as, "I'm being mistakenly anthropomorphic here." On the other hand, ironically, theorists treat natural selection as if it's a force unto itself. For example, in the current Wikipedia entry on natural selection acts on the phenotype, the characteristics of the organism which actually interact with the environment, but the genetic, heritable basis of any phenotype that gives that phenotype a reproductive advantage may become more common in a population. Note how natural selection is active. It acts on the phenotype, as if it were a process apart from the actions of the living thing. As defined on the National Geographic Resource Library, natural selection is the process through which populations of living organisms adapt and change. Individuals in a population are naturally variable, meaning that they are all different in some ways. This variation means that some individuals have traits better suited to the environment than others. Individuals with adaptive traits that give them some advantage, are more likely to survive and reproduce. These individuals then pass the adaptive traits on to their offspring. Over time, these advantageous traits become more common in the population. Through this process of natural selection, favorable traits are transmitted through generations. In this account, organisms that have traits that allow them to survive are able to reproduce and pass on their traits. An example often used, black squirrels rather than gray are more likely to survive in a sooty environment. Plants such as cacti and aloe, living in desert environments, developed fleshy leaves that store water for them, as do the humps in camels' backs. It is the characteristics of the life forms that enable it to remain alive. These characteristics are called adaptations. Consider the uses and meanings of adaptations. At the Cambridge Online Dictionary, the entry for adapt says the following: to change, or to change something, to suit different conditions or uses. Many software companies have adapted popular programs to the new operating system. The recipe here is a pork roast adapted from Caroline O'Neill's book, Louisiana Kitchen. We had to adapt our plans to fit Jack's schedule. The play had been adapted for equals change to make it suitable for children. Davies is busy adapting Brinkworth's latest novel for television. If a living thing adapts, it changes slightly over time, so it can continue to exist in a particular environment. Species have adapted to climate changes throughout history. The ways in which organisms have adapted to survive in this extreme environment are not well understood. Note that all the examples in the initial definition are of actions humans chose in order to fulfill a human need or want, that is, goal-directed action. And notice that in the biological examples, passive voice is not used. For example, species were adapted to climate changes throughout history, which would imply an outside force caused the adaptive change. Rather, adapt is used in the active sense. That is, the species are acting to change themselves to fit the environment. Ironically, the second species example says it all. How organisms adapt isn't well understood. My point being that the biological conception of adaptation is all very confused and muddled. Biologists do not seem to be thinking clearly about the situation. By using the word adapt in the definition of natural selection, the sense of the living thing having active goal-directedness is implied, but not acknowledged. Natural selection is used as if it is a selecting process, as if the environment were a goal-directed selector when in fact it's the organism's actions to survive, its self-directed response to the conditions of its environment, that does the selecting. The squirrel forages. The rose grows new roots reaching for the nearby water. The bee flies ever new courses in search of pollen. Of course, Darwin is right. The survival of many organisms of a certain type causes those organisms to affect the course of evolution. But organisms are not rocks. They don't just sit there and things happen to them. It is the organisms constantly acting to survive that causes them to survive. If their abilities fail it in this regard, and they die before reproducing, and new ones of their kind simply do not exist. As James Lennox points out, 1993, Darwin himself recognized the teleological nature of his ideas with his consistent arguments that natural selection acts for the good of each being, and that its products are present for various functions, purposes, and ends. Darwin, 1964, 149, 152, 224, 237, 451, 411. Some contemporary scientists continue to wrestle with many of the features of life that don't comport with the neo-Darwinist approach, essentialized by Daniel Dennett, 1993, as reduce or even eliminate teleology via a mechanistic model of natural selection, 389. Consequently, neo-Darwinists incorporate the view that adaptive change is entirely random and natural selection determines which species continue or die off. For example, some biologists have admitted to the reality of function, for example, that features of living things have a role in maintaining their lives, that is, are goal-directed. The wing's function is to allow a bird to fly away from the cat trying to capture it. However, these neo-teleologists take a limited approach to the issue. For example, in the following quotes, Koestler, 2016, admits some specific goal-directedness, but denies that it's anything but within the mechanistic framework. In Aristotelian biology, the final state of living processes is something aimed at. In neo-teleological approaches, the concept of telos is understood as final state directedness. But here, the final state of a material process is considered to be achieved by blind, deterministic, non-mental factors alone, 415. On the basis of the evolutionary approach, the functions of organisms are adaptations packaged together into larger units, that is to say, in the organisms themselves. Rosenberg, 2007, 123. Evolutionary explanations of function rest upon an implicit evaluation of functions. Functions are positively selected adaptations because they are beneficial to organisms. McLaughlin, 2005, 29. In modern biology, something is regarded as contributing in favor of an organism if it increases its so-called fitness, that is, its probability to stay alive and its ability to propagate. 418. And other scientists point out the problems with seeing random mutation and natural selection as the only processes causing evolution. Natural selection doesn't explain certain characteristics, said Ard Louis, a biophysicist at Oxford University, in an email. These characteristics include a heritable change to gene expression called methylation, increases in complexity in the absence of natural selection, and certain molecular changes Louis has recently studied, Wolchover, 2014. It seems that the proper scientific attitude should be, if it walks like a duck, talks like a duck, and looks like a duck, it's a duck. Our task then becomes to explain how this duckness, this ability to self-organize and initiate physical and mental action, works in a naturalistic manner. With the development of a certain kind of physical order and process, living organization and living process, comes self-directed action aimed at keeping itself in existence. It needs certain conditions to do so, including food fuel, although these conditions vary wildly, from the high pressure and temperature of the Marianas Trench to the frozen tundra of Antarctica. Its self-directed nature enables it to creatively respond to varying conditions. The ability to act toward goals to survive is the very essence of being alive. It's natural. It's creative. As a scientific issue, it's just up to us to figure out how. Fortunately, there have been some brilliant thinkers working on that, such as Ludwig von Bertalanffy and Arthur Koestler. How does a hard-headed rationalist reconcile the nature of life with physics, not by merely shoehorning life and consciousness into the physical principles we already know? We must expand our understanding of nature and discover new concepts and principles to guide our thinking. Let's see what ideas have helped and what ideas have hindered this process. Mystical spirits versus Aristotelian soul, the philosophical quandaries. In the past 500 years, philosophers of science and thinkers of the scientific revolution took the brilliant principles of physics and chemistry that Galileo, Kepler, Newton, Lavoisier, and others discovered and successfully applied them to the inanimate world. And technologists used them to build fabulous machines that continue to transform human life. This work was based on the discovery of the principles of mechanics and electromagnetism, optics, chemistry, and the analysis of many phenomena through reducing their structures and actions to their parts and subparts and demonstrating how the nature of the subparts cause the features of the inanimate. For example, as the FAQ page on the website for the International Association for the Properties of Water and Steam explains, the reason that ice floats is water's unusual tendency to expand rather than contract when it becomes a solid, which is caused by its hydrogen bonds, that is, the nature of its constituent parts. There is a strong tendency to form a network of hydrogen bonds, where each hydrogen atom is in a line between two oxygen atoms. This hydrogen bonding tendency gets stronger as the temperature gets lower because there is less thermal energy to shake the hydrogen bonds out of position. The ice structure is completely hydrogen bonded, and these bonds force the crystalline structure to be very open. It is this open solid structure that causes ice to be less dense than liquid water. That is why ice floats on water, for which we should all be thankful, because if water behaved normally, many bodies of water would freeze solid in the winter, killing all the life within them. A fabulously informative analysis, but the theoreticians and philosophers of science have been like little boys with hammers. Every subject has been a nail. They have insisted that reducing all things to their physical and chemical elements is the only scientific basis for explanation. This reductionist confusion was fueled by the acceptance of David Hume's 1737 skepticism and sleight of hand in equating causation with something directly perceived. It appears that in single instances of the operation of bodies, we never can, by our utmost scrutiny, discover anything but one event following another, without being able to comprehend any force or power by which the cause operates, or any connection between it and its supposed effect. The same difficulty occurs in contemplating the operations of mind on body, where we observe, emphasis added, the motion of the latter to follow upon the volition of the former, but are not able to observe or conceive, emphasis added, the tie which binds together the motion and volition, or the energy by which the mind produces this effect. The authority of the will over its own faculties and ideas is not a whit more comprehensible, so that, upon the whole, there appears not, throughout all nature, any one instance of connection which is conceivable by us. All events seem entirely loose and separate. One event follows another, but we never can observe any tie between them. Emphasis added. They seemed conjoined, but never connected. And as we can have no idea of anything which never appeared to our outward sense or inward sentiment, the necessary conclusion seems to be that we have no idea of connection or force at all, and that these words are absolutely without meaning when employed either in philosophical reasonings or common life. The idea of power, or a necessary connection among events, arises from a number of similar instances, which occur of the constant conjunction of these events. Nor can the idea ever be suggested by any one of these instances, surveyed in all possible lights and positions. After a repetition of similar instances, the mind is carried by habit upon the appearance of one event to expect its usual attendant. 40 to 41, emphases in original except where noted. Here, Hume seems to have reduced the mind to perception. He didn't observe any causes, only one concrete thing touching another and the other moving. He claims the mind forms a habit of expecting to see causation. He seems to refuse to acknowledge that causation is an abstraction from the concrete events we experience, a conclusion and an inference from those concretes. He does not abstract from the actions his eyes could see. The fact of the matter is, we don't see causation as such. 6. We see individual actions, events, forms, and materials, and we generalize from them to form the idea of causation. Moreover, Hume seems to equate all causes with that of an outside force, traditionally called an efficient cause. He doesn't identify any principles about the entity that might be causing change and recognize other kinds of causation. Hume's approach is a result of the problem of induction. How do we abstract from the concretes we see before us? 7. He does not abstract from his observations to the causes, no matter that he's using inductions and abstractions in everything he says. 8. Unfortunately, since science is dependent on philosophy to correctly identify principles of knowledge, and philosophy has been stuck on the question of induction for the past few centuries, it succumbed to this anti-conceptual nonsense. What's needed is a different gestalt about the animate and inanimate with regard to what's understood as scientific causation, really a return to an ancient Greek view of causation. First, to recognize that action is caused by the nature of the entities acting. Aristotle identified 4 possible causes of any change, 2,300-odd years ago, in his Physics, 1970, Book 2, Chapter 3, 194b29, and Metaphysics, 1970, Book 5, Chapter 2. 1. The material or what something is made from, such as granite or flesh. 2. The formal, its shape or configuration, such as a helix or a feedback system. 3. The efficient, sometimes called proximate, the agent acting on something, such as a painter painting a house. 4. The final, the end toward which it acts, either purposive or goal-oriented, such as forming a new government or reproducing, or acting in accordance with nature, as a rock falling when hit by another rock. Aristotle uses end to account for the regularity of all action, inanimate as well as animate. A closed system moving toward its end state is entropic. Scientists were so eager to throw out teleology, which had dominated views in the Middle Ages, that they threw out teleological, that is, goal-oriented final causation for living things, as a relic of the pre-scientific world of spirits and the supernatural. In contrast, for example, Newton's first law of motion incorporates Aristotle's end-state view of the inanimate, with a body remains at rest or in motion at a constant speed in a straight line unless acted upon by a force. In other words, the state of a body is in accordance with its nature unless acted upon by another body. And Newton and the thinkers of the scientific revolution kept the metaphor of biological teleology by calling the scientific principles they discovered laws on an analogy with human or God-given directives. Modern science only recognizes the first 3 Aristotelian causes for non-conscious beings, except when it slides the last in the back door with terms like struggle, as in the struggle for existence, or law of motion. Struggle does not mean something being acted upon, but 2 or more entities acting upon each other in a goal-oriented manner. In normal, literal parlance, we never speak of lava struggling to transform into rock. To reiterate, As mentioned, the term natural selection itself smuggles in the sense of goal-orientedness with the word selection. Who's selecting? The environment. That reifies the environment into an agent acting upon living things. It is similar to the use of market to explain the myriad processes of human economic actions. The use of the term market seems to attribute agency to the system as a whole when, in fact, it is the individual actors causing the outcomes. As long as we're clear that environment and market are a shorthand way to refer to this combined action, conceptual confusions won't follow. Let's be clear. Scientists have thrown out final causation because they could not see how the final cause could be naturalistic. That is, how non-conscious living beings could act toward goals or ends without invoking some consciousness, some mystical spirit or force. Consequently, a reductionist view of causation has reigned along with the reductionist method. Their error was in assuming that if living things could not act toward goals by some mechano-reductionist means, then the only alternative explanation is an elan vital, a special supernatural spirit or force that enabled the actions, a view called vitalism. 9. Unfortunately, as discussed, this dichotomy, mechano-reductionism versus vitalism, went back to the ancient Greeks and reappeared during the Renaissance, with Descartes as the greatest proponent of mechano-reductionism. In the ancient world, Aristotle took a non-reductionist, naturalistic approach to living organisms, and he disposed of the mechano-reductionist arguments in his Peripsyche, usually translated as on the soul. But modern scientists have mostly ignored him, his philosophy, and his investigations of biology. Probably they have done so partly as a legacy of the spiritualist dogmatic interpretations of his ideas when he was the philosopher of the Catholic Church, from which science had to free itself. In fact, most modern biologists are unaware of his ideas or the fact that he founded the science of biology and scientific investigation itself with his work in parts of animals, history of animals, movement of animals, on generation and corruption, on the soul, and in the prior analytics and posterior analytics. Often dismissed in the 19th century, his brilliant observations were eventually recognized as astoundingly accurate. Here are some examples from the Wikipedia entry on History of Animals. Some of Aristotle's observations were not taken seriously by science until they were independently rediscovered in the 19th century. For example, he recorded that male octopuses have a hectocotylus, a tentacle which stores sperm and which can transfer it into the female's body. Sometimes it snaps off during mating. Thomson, 1910, 524. The account was dismissed as fanciful until the French naturalist Georges Cuvier described it in his 1817 Le Règne animal, Alibi, 2010, 34. Aristotle also noted that the young of the dogfish grow inside their mother's body, attached by a cord to something like a placenta, a yolk sac. This was confirmed in 1842 by the German zoologist Johannes Peter Müller, 34. Aristotle noted, too, that a river catfish, which he called the glanus, cares for its young, as the female leaves after giving birth. The male guards the eggs for 40 or 50 days, chasing off small fish which threaten the eggs and making a murmuring noise. The Swiss-American zoologist Louis Agassiz found the account to be correct in 1890. Leroy, 2014-69. James Lennox, 2021, comments. In the 19th century, the great anatomist Richard Owen introduced a survey of Aristotle's zoological studies by declaring that zoological science sprang from his Aristotle's labors, we may almost say, like Minerva from the head of Jove, in a state of noble and splendid maturity. Owen, 1992-91. In his informative recounting of Aristotle's work in the Lagoon, How Aristotle Invented Science, 2014, Armand-Marie Leroy, professor of evolutionary developmental biology at Imperial College London, astonishedly admitted his total lack of tutelage in Aristotle's founding of the science. In Book 2 of On the Soul, Aristotle said life was the psyche, or soul, by which he meant the organizing principle of a living thing. The soul is the first actualization of a natural body which possesses life potentially, 1957, 411b, 20-30, and the soul is a sort of arrangement and form, but not the matter and underlying subject, 414a, 13-14. Translating psyche as soul unfortunately evokes that word's supernatural connotations. In other words, Aristotle thinks the essence of life is a certain kind of arrangement of matter. He had the tiger by the tail. When science turned away from Aristotle because of apparently mystical ideas, they threw out a valuable baby with the holy water.